It's a really easy question.
I think what we're talking about is what's at the very edge.
Hello and welcome to the Edge Tech Podcast. I'm David Kosloski. Today we're talking about BMC and the future of nano BMC. Today next to me I've got Mr. Steve Savage, the Chief Operating Officer at SNUC. Steve, thanks for coming.
Thanks, David. Thanks for having me.
And I've got Chuck Abdouch. Am I saying that right?
Close enough.
All right, Chief Technology Officer at SNUC. Chuck, thanks for being here.
Thank you, David.
Awesome. Now that I butchered your last name, I've got a very serious question. It's actually very simple. I think we all know that most listeners that are listening to this probably know what BMC is, but let's just set the scene, if you will. What is BMC?
BMC is an acronym for Baseboard Management Controller, and it's you could think of it as a very simple computer whose role is to monitor the health of a more complex computer.
Okay. Any flavor you want to add to that, Mr. Steve?
The BMC also adds a remote management functionality to it. So it allows you to control, monitor, modify a device out in the field that you may not have easy access to in different environments. So you don't have to roll a truck every time you need to make a modification or a change.
Yeah, I think that's a good segue into what are some of the benefits of BMC? You just mentioned obviously rolling the truck, but can you give some examples?
So as Steve alluded to, that it has this remote capability. So if you can imagine a data center where you have 1,200 servers in racks, back in the 70s, you would have people that would walk around looking at these systems and constantly checking their health. And what the BMC did, and so in the 80s, servers started getting BMCs, and nowadays there's no data center that doesn't have one. And so from an IT professional's desk, he's got an application that could be watching 10,000 servers. And one of them has a fan failure, and he gets a little pop-up saying this one, the fan failed on it, or temperatures are starting to go up. And instead of having to go search for this server, he can now interact with the server remotely to start diagnosing problems and see if he can resolve issues.
Sure.
So that was the primary reason that it came about. But once that capability was in place, it was quickly decided, hey, can we re-image OSs remotely? And can we change boot order remotely? And can we make other system adjustments remotely? And so those capabilities quickly entered the capability of the BMC.
Yeah. And when we talk about BMC you're mentioning that this individual has a computer screen that's monitoring the servers. What would be the benefit of if I'm in an office being able to see, the server room can't be far. So why do I need BMC? I could just walk over there.
Well, because when you walk in a server room, it's very loud.
Okay.
Secondly is you have each rack could have 42 servers in it, and you may have a row of 20 or 30 racks. So you have hundreds of servers. Also, there's not monitor, keyboard, and mouse attached to these things. So you typically have a rolling cart that you roll over to a server and you plug into it so that then you can see what the video is and you can interact with the server. All of that capability is done through the BMC remotely from your desk. So if you want to see a particular server's running a job, now we're not talking about the BMC, but the server itself, I can link through the BMC into the server and I can bring the video up right at my desk. I can type on my keyboard and it's like having a keyboard plugged in that system. And so I'm interacting with that server remotely to maybe check on its health, how loaded down, like if I'm selling services, how loaded down is that server? Is it not providing the performance to the people renting time on it that I've guaranteed them to have? And so I can kind of interact and make sure that customers are happy with the hardware. Sure. And then when there is a failure, that the BMC tells me early. For instance, the server is running in a 70-degree room. As the server normally runs 82 degrees, well, now it hits 84 degrees, and the BMC is saying, hey, I'm having an issue. I've turned the fans all the way up to full, and the temperature's still rising. Now I've got a wide margin to the failure point of 100 degrees, but well before the failure point, I'm getting some notification that there may be a problem going on.
So are you telling me that the BMC device not only is a remote control, but it's also going to alert you in certain situations?
Yeah.
Interesting. And then it sounds like in conversations, I know we spoke with a gentleman recently, another CTO, about all these benefits, but it sounds like there might still be some limitations with BMC. Are there any that you can think of or that you want to discuss?
Well, they can't pull a bad hard drive out and swap it out for you. You
Sure.
still have to walk in. But most failures of servers is resolved with a reboot. Number one solution to almost any computer failure is a reboot resolves it, right? And so if the BMC can simply power cycle the system, you've knocked out more than 90% of your resolution capability. And you can have an IT guy, for instance, you have a data center here in Round Rock, but you have IT guys running different time zones. And so in the middle of the night, somebody in Australia gets a message that a server's gone down, and from thousands of miles away, he can reboot the server and then see if it comes back up online. And if not, then he can start shifting loads over to another system to handle that one, and then schedule a service tech to go look at it.
Is there? Yeah, I was to say that. What do we got, Steve?
Yeah, and if you think about that at the edge, right now on the edge, you have a much more complex problem in that you don't have 1,200 servers sitting in a row of racks, right? Where worst case, you can get up and walk to the floor to dig into that and see what the issue is, or log into it there locally. Now you got them on light poles, you got them down in tunnels, maybe they're traveling on a bus. So you need to determine what's going on kind of real time. You don't want to spend the time and money to roll a truck out to that site to get the device. So now you're able to do that remotely, where you don't need to get on a ladder and climb up to a light pole, to see what's going on with your edge device, or in the back of a quick serve restaurant. You can remotely log in, take a look at that, do the reboot, push a new image, and kind of do diagnostics before you worry about sending someone out.
Right.
to
Reducing
the
truck
site.
rolls. Well, number one capability is you're reducing truck rolls.
Yeah. Thanks for setting kind of the tone of what BMC is, the features of it, the benefits of it. I want to touch on something. This company will remain nameless from here on out. Okay. We know, and I know we know who we're talking about, but there was a particular incident that had happened where airports had to sort of stop flights. They had to reboot computers manually, remove a couple files within the computer, and then reboot it again. This happened at 911 centers and a few other areas, and this organization ran into what I would say catastrophic. And in a situation like this, would BMC have solved the problem?
Oh, absolutely. The nice thing about, so on the BMC world, there's kind of two different software versions of BMC. And the second one, you can actually write scripts. So you can, from your local computer, write a script to go out to every BMC that your computer knows about and actually reboot all of them remotely. And instead of logging into 10,000 computers, you can actually write a script to just go do that.
And in this situation, is it possible that the reason that BMC wasn't in there was because it's too big? I mean, not for the tech we're going to talk about here in a second, but is that maybe why there wasn't BMC enabled in these devices? Or
there was a couple of reasons. First, there's diagnosis of what was causing the failure. Rebooting the computer could have just had it fail again. So there was a short time while they decided what had happened. The second thing is, as I mentioned, there's kind of two flavors to BMC. In the 1980s, the first version of BMC had a program called IPMI, Intelligent Platform Management Interface. And so nowadays, all BMCs support IPMI. But there's a new spec that came along called Redfish API, and it's a software API that you can write software to connect to. And so BMCs that support the Redfish means you can now script. And so it's very likely that most of the internet hardware that exists today, these multi-tens of thousands of dollars of servers and data centers, only have the original IPMI. So they're not scriptable.
Gotcha. And Steve, this is where I'm really going to throw it into, because I know you're probably itching for this. This is I feel like your guys' baby here. But we're getting into this new world where the company we all work for created and invented something called Nano BMC. And I guess, Steve, what is the difference between BMC and Nano BMC?
So Nano BMC, the secret to that is the size, the price, and the functionality. All right, so we're able to take the BMC functionality and embed that in an edge device that's deployable to the extreme edge. Right, so we've changed the paradigm of, hey, BMC only exists in servers. Well, now it exists in small form factor edge devices that are extremely deployable, extremely reliable, and ruggedized, that can be used at the edge and limit the amount of touches you need in the field.
And when you guys talk about the edge, like what businesses, Chuck, do you think are actually? I've heard examples of like QSRs, but like do these QSRs that are in a kitchen really need this extreme edge device? Or they really need BMC or nano BMC?
They really do. One of the worst environments that you have is fryers. And when you go into certain quick serve restaurants and you look at the fryers, you look overhead and right above them is a computer. That computer is a harsh environment computer, right? They don't know that, but when they bought it, they bought this expensive computer that had to survive that environment. When we talk about servers, like we're talking about edge servers. What's the difference in a server and an edge server? So if you go look at what a traditional server is, it goes into an air-conditioned room. Typically, the temperature of that room, the fresh air entering will never be more than 72 degrees. And so for our edge servers, we're expecting that the temperature entering it could be 115 degrees Fahrenheit. And it has to survive because it could be up on a light pole. It could be up on a cell tower running a backhaul. So it could be in some harsh environments where you can't control the temperature. And so you need the hardware to survive that. And along with that is the traditional BMC isn't meant for that environment either. So we had to have kind of a harsh environment, ruggedized BMC.
Well, I think that's the question is like, or one of the questions that I'm getting to is that why wouldn't, if I'm a quick service restaurant, or if I have a sensor at a train track, why did I not choose to do a traditional BMC? Like,
because it wasn't available.
It wasn't available, but traditional would be available in that area, or
no. There's no. The only non-data center systems that have BMC are workstations. There's a few workstations that they started adding BMC to them. But when you talk about a traffic light controller or a thing watching your fries cook, and one of our favorite restaurants where they're literally watching how aged the tenders are and telling them that they're not cycling the tenders and telling them to throw away the tenders because they're not fresh. They actually have a camera looking at the tenders and looking at each one, right? So now you need pretty sophisticated computing power with AI, and those platforms would either be big rack servers, which you're not going to put in that environment, or they're not going to have BMC. It's just not normally found in these environments.
Yeah. So can you guys give me some examples of businesses that would utilize nano BMC versus BMC? I know we talked about the quick service restaurant, but is there any others that you can think of?
Every single computer that is unmanaged, you've got your desktop PC, you're using your desktop. If it acts up, you know. But you walk through a hotel or an airport and you see 100 arrival departure screens. There's nobody standing there watching that system if it's operational. Recently, we were with a customer walking through and one of the departure screens was down. So he has to reach behind and pull the plug and plug it back in and wait there for it to come back up. The only way he knew that it was down is he visually saw it was down. And then he physically reached behind and found the power cord and pulled the power. So when you talk about a system that is remote, and you can think of a lot of systems that are remote, especially digital signage, it's a must that you have remote management. Now, we have some systems that had vPro remote management in it. And vPro is kind of a stripped down BMC. But when Intel added vPro, they only added it to their most expensive processors, and they added a $150 step fee for having the feature. So wouldn't it be better to have a $100 step fee to add BMC to an inexpensive computer? I don't need it in my i9, I need it in my Celeron, because my digital signage doesn't require a $2,000 i9, it requires a $500 Celeron. But I can't get that one with vPro. But now you can get it with BMC.
Sure. Steve, you got any other businesses that you're thinking of that?
Yeah, so some of the DoD customers we have are using them as endpoint, like packet sniffing devices. right? So these are deployed in very remote areas that it's difficult to get a person to, but they also need remote access in case they get a signal that there's a problem with the feed coming into the system. So now remotely, right, they can access the device, turn it off, add new software, modify the configuration, and they can do that real time. They can do it quickly without having to wait and send someone out to that site.
Yeah. This is something that you're saying, it sounds like we're in this era where the tech is evolving in real time, and we're now creating new solutions to problems that we're dealing with. And is the example you're using, is it truly something where this is a new solution to an issue that has never been able to be solved before, and this Nano BMC device is helping make that happen?
Yeah, so there's technology. So having technology in quick serve restaurants, having servers in the back office, having packet sniffing devices is not new. What we're solving is the ability to quickly modify and adjust and adapt to the environment and the threats that could be out there. So at the BMC, you're able to quickly get to the device and modify or make changes to that, where in the past you would have spent time and the threat could linger while you try to get to the device.
Imagine that you had to send techs out to update 100,000 firewalls.
Yeah. So it's existed before, the small compute, but now it has the ability to reduce the time to go reset, reduce
Right.
the
Remove truck rolls.
Yeah. So going into that, Nano BMC is it sounds like it's infancy stage. So what's the future of it?
So currently, Nano BMC is simply SNUC's name for it. And I do want to cover the two challenges we had was to miniaturize it so it could fit in smaller computers, because the traditional BMC was about the size of our computer. And the second is a traditional BMC is about the cost of a small computer, and we need to get that cost down. And so as we did that, we also faced another challenge that most of the software is licensed. And so our end users would have to pay licensing fees, right? And so by us authoring the code ourselves, we could just make it part of the hardware cost, and it's a forever license. So now these users aren't going to, like 2 years from now, have to buy a new copy of firmware to get another 2-year license. And so in doing that, we decided kind of what features do customers need now? And we created a critical feature list that we implemented. And then features we want to get to in short term before the end of this year. And then some long-term features to add. For instance, today, all of our systems are fanless. So we didn't need the BMC to monitor fan RPMs or temperatures. Well, it does do the temperatures, but we don't monitor the fans because we don't have fans. But we know that fans are coming, and so we're going to turn those features on here soon. And so KVM, which is remote video. So most servers are Linux-based. And Linux-based works really good with remote systems. You've got a console window or you have a GUI that works over a serial connection to your unit. Windows doesn't work like that. Windows really wants a monitor to show you the video. And so on our units, we're capturing one of the monitor ports from the processor, the system processor, and we're feeding that into the BMC. And so it's putting out video, and soon we'll have a version of the Nano BMC that will take that video and forward it remotely so that now we can work with Windows servers as well.
That's awesome.
And so we've got kind of a feature set that we're going to keep rolling in there. And we don't think that we're behind our customer needs. Right now, our customers are happy with all the features we've issued them, but it's continuing to add features you would find in a traditional BMC that makes sense in this environment and an edge server.
Yeah.
And some of the things that I think make us unique and the Nano BMC unique is not just what it currently does, but also the way we interact with our customers, right? So as we deploy the units, as our customers deploy them and use them in their environments, they're giving us feedback of feature sets that they would like to see, things they'd like added. So we're able to take that, interact with them, and roll those into our pipeline and see, hey, can we add that in the next release? So we've been able to really engage with our customers, which is part of our value add, is how do we solve our customers' problems, right? And how do we enable them and enhance their experience with the product for their environment, because they're all a little bit different. So everyone has a little bit different use cases. And so it allows us a good opportunity to work with them to understand what features are important to them. And then we spend our time developing the features that are meaningful to our customers, as opposed to just, develop and hope that somebody needs it. So we really try to engage with our customer to understand and listen to what their needs are and how do we address those.
Yeah, it's great. What I appreciate hearing the, without being salesy of what we're doing at Simply SNUC. I think the idea of, hey, this is a new tech and it's evolving, and we have to be able to hear from the people using it to make it better. And I think that just has to be said. So I appreciate you guys jumping on and talking about BMC and the future of Nano BMC. It means a lot. So thanks for being here. And thank you all for listening to the Edge Tech Podcast. I'm David Kosloski. If you like this episode, please make sure to like, share, subscribe. It means a lot. Take care.